Alright, so this is a review of the 7.3 Measuring and Predicting Earthquake Review questions. These questions were included with the notes and should have been answered in your notebook as a classwork assignment. Alright, so the first question is about, seismographs and how do they record movement if they're moving with the Earth? Well, part of that answer is that they're weighted, and that means that their own inertia keeps them from moving the same way that everything else moves around them. Think about it this way. If you shake a semi-truck and you shake a Volkswagen Bug, one is going to move more than the other, right? And also, they can make adjustments for the small amount that it does move, and especially modern ones, use electronic motion detectors, so they're more accurate. Right? On a seismogram, when do the waves arrive? Well, the P waves arrive first, the S waves arrive second. This should be easy to remember because P in P waves stands for primary waves. S stands for secondary waves, right? But remember, the S waves don't always show up, depending on where the earthquake is relative to the seismogram or seismograph. The surface waves arrive last, and you're pretty much always going to get P waves and surface waves. But if the waves have to travel through the liquid outer core, S waves cannot go through a liquid. All right. Number 3, what do you need to calculate the distance from the seismic station to the epicenter? You need the time between the P wave and the S wave. The greater the difference between the P wave and the S wave arrival times, the farther away the seismic station is. So that is a direct relationship. If one increases, the other factor increases as well. All right. Number 4, if a seismogram records P waves and S waves, P waves and surface waves, but not S waves, what do you know about the location of the earthquake? Well, we know it's on the opposite side of the Earth, right? Because the S waves cannot travel through a liquid. And the S waves would only completely travel through the liquid part of the core if they were on the opposite side of the Earth. All right, on the Richter scale and the magnitude moment scale, the energy released is measured in magnitudes of 30, right, or factors of 30. So if you have a magnitude 7 versus a magnitude 8, that is an increase of 30 times the energy. If it's from a 7 to a 9, that's 2 increases of 30 times. So that's 30 times 30, or 900 times the energy. Number 6, why do you need at least 3 seismographs to locate an earthquake epicenter? Right? To locate an earthquake epicenter, you need at least 3 seismographs because you can determine only how far away the epicenter is from one seismograph. That's all you can tell. You can tell how far away it is, and that's it. But if you have 3 seismograph data, at the minimum, if you have 3, you can draw a circle around each one using the distance as radius. And then where those 3 circles connect, that is the epicenter. All right, number 7. What are the problems for the Mercalli scale? The Mercalli scale, in one word, is subjective. It does not directly measure the earthquake magnitude. Instead, it measures how people felt during the earthquake. What did they feel? Did they feel that it was a really bad earthquake or not so bad? How did it affect the buildings? Well, all of that is subjective. You take a magnitude 1 earthquake in California and a magnitude 1 earthquake in California or in North Carolina, you're going to get different results. There's going to be more damage in North Carolina because our buildings aren't built to withstand earthquakes because we don't get them. Okay. The Richter and moment scale were developed because they needed a way to directly measure the earthquake's energy release. All right. Why is the moment magnitude scale thought to be more accurate than the Richter scale? The Richter scale only measures the magnitude of the largest jolts. So like earthquake, 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 big rumble, earthquake, earthquake, earthquake. All of this earthquake is ignored on the Richter scale, and only this is considered. On the moment magnitude scale, you're looking at all of the energy release, not just the biggest spike. Number 9, on both scales, again, the energy released is 30 times more for each level of magnitude. So a 7 releases 30 times as much energy as a 6. Number 10, we can predict where earthquakes would be likely to happen, but we cannot predict when they will happen. Now, foreshocks are tremors that usually precede a major earthquake. But the thing is, if you have small tremors and then a big earthquake, then we call those small tremors foreshocks. But if you just have the small tremors and no major earthquake, then it's just a small earthquake, right? So they don't always precede a major earthquake. And even when they do, we don't know. It could be a few seconds before the major earthquake. It could be weeks before the major earthquake. We just don't know. Okay. What would be a good, useful prediction? It would have to have the place, time, and the magnitude that the earthquake would be. All right. And so that's that. Now, the other thing I wanted to go over quickly was the graded assignment that you had. All right. So measuring, predicting earthquakes. If the seismograph records P waves but no S waves, we know it's on the opposite side of the planet. That question was directly in your review questions. So that's why it's important to do those. So when I give you an open notebook assignment, you have that work. How often do earthquakes with a magnitude 8 to 8.9 occur? About once a year, statistically speaking. We don't know I mean, we could certainly have more, we could certainly have fewer. Seem to be having some internet trouble. All right, number 3, the difference in arrival times between which pair of waves can be used to determine the distance to the epicenter. It's the S and P waves, but that option is not available. So the answer was none of the above. Remember, the S in S wave stands for secondary, not surface. All right, number 4, the amplitude of the largest wave on the Richter scale is magnitude 8. How much more is that than a magnitude of 6? So when we talk about magnitude, all right, then it's a factor of 10 because it's a logarithmic scale. When we talk about energy, it's a factor of 30. I know that's confusing, and I probably won't put it on the test, but that's the difference. Number 5, what causes the up and down wiggles in the seismogram shown above? Ground vibrations. I didn't even put the diagram in there. That's my bad, but honestly, you don't need it. Ground vibrations, that's what an earthquake is. All right, number 6, where is the focus with respect to the epicenter? The focus is where the earthquake actually happens. It's directly below the epicenter. Which of the following measures an earthquake's intensity based on the observed effects? That's the Mercalli scale. And we don't use that anymore because it's too subjective. Which of the following statements best describes the state of earthquake prediction? We can characterize the risk of an area, the likelihood that an area will have an earthquake. California is more likely to have an earthquake than North Carolina. Okay, but we cannot predict when earthquakes will occur. The longer the difference in arrival time of the first P wave and the S wave, the farther away the epicenter is. Number 10, which of the following statements is true? As the distance to the earthquake increases, the elapsed time between the arrival of the P and S wave increases. Charles Richter helped find the procedure to help measure earthquakes. Number 12, on the moment scale, between a 7 and a 9, that's 2 steps of magnitude, and we're talking about energy release here. So that's 30 times 30, or 900 times the energy released. All right. Number 13, seismographs can help determine the intensity. Yes. Number 14 was false to start with. The time between the S and P waves of the earthquake is directly related to its distance from the epicenter. Number 15 is true. Number 16, scientists have easier time predicting where an earthquake will occur than when. So the original statement was false. The corrected statement you see there with green. Number 17, the time difference between the S and P wave shows the distance to the earthquake, not the intensity. So the original statement was false, and you see the correction in green. All right, that's what we went over today in class. I hope this helps you study. The midterm will be everything from the first day of school all the way up to the end of the earthquake chapter. All right, so what we just went over, that will be on there. All right, have a good day, and we'll see you class. Did that not record? I'm confused. I'm really confused. Don't tell me I just did that whole thing and it didn't record. I'm confused.